Hey everybody, Miss Martello here. In this video I'm going to show you how to find the multiplicative inverse of a 2 by 2 matrix. I'm going to show you the way that I think students might use if they were just discovering this for the first time. So students would probably be given the idea that when you have a matrix, say like this one where in the first row I have 3, 2, and in the second row I have negative 1, 4, that multiplying that matrix by its inverse would be giving you the multiplicative identity matrix, which is in the first row 1, 0, and then 0, 1 in the second row. So again, when we multiply a matrix by its inverse, we should be getting the identity matrix. So we're looking to find the inverse, which is going to be this matrix right here. So when you might do that, if you were just doing it for the first time, maybe you would think to multiply these two matrices together, because we have a 2 by 2 matrix with a 2 by 2 matrix, so we are allowed to multiply them. So if we did that, I would make sure I'm using my matrix multiplication rules. So say that I'm looking at getting this spot first, this element in the matrix first. This would be my first row, first column of the matrix. So then when I multiply them, I need to look at the first row of this matrix with the first column of this one. So I'd start by doing 3 times A, and then 2 times C. If I go to this spot next, I'm still in the first row of the matrix, but now I've moved over to the second column. So then I'm still looking at this first row here, but then I have to look at the second column. So that'd be 3 times B with 2 times D. Then when I come down here, now I'm in the second row, but the first column. So then I have to look at the second row of this matrix, but the first row of this one. So that'd be negative 1 times A with 4 times C. So again, negative 1 times A plus 4 times C. And then my last spot would be still the second row, but the second column. So I'm looking at my second row here, and then my second column here. So that'd be negative 1 times B with 4 times D. So this is going to be the product of these two matrices. So I'm essentially bringing that down, but I multiplied them together. And then I can, just like a normal equation, I'd bring down the equals and whatever's on the other side. And on the other side happens to be the identity matrix, so I have that there. But now I have a 2 by 2 matrix equal to a 2 by 2 matrix. So that means that whatever's in this spot here should be equal to 1, because they're corresponding. Whatever's in this spot, 3b plus 2d, that should be equal to the 0, because they're in the same spot. This should be equal to this, because they're in the same spot. And this should be equal to this, because they're in the same spot. So essentially from that, what I'm saying then is that 3a plus 2c, that should be equal to 1. And then the negative a plus 4c should be equal to 0. You might notice that I have two different equations, and there's an a and a c in there. So 2 equations with 2 unique variables. That's a system of linear equations like you've already learned to solve. In the same way, when I look at these, like this column of the matrix, I should have that 3b plus 2d would be equal to 0, and then the opposite of b plus 4d would be equal to 1. So again, I have another system of linear equations because I have 2 equations with 2 variables. Now it's b and d. So I should be able to solve for a and c using this system, and then b and d using that system. So if I look back up at my goal, if I'm looking for the values of all of these variables, these two systems will help me find the value of all 4 variables. So I'm going to go through these systems. It looks like they're set up pretty nicely for the elimination method. There definitely are different ways that you could go through solving them using the elimination method. I think that I'm going to take the second equation and multiply it by 3 so that I can eliminate the variable a. If I do that, I'm going to keep the first equation the same, so 3a plus 2c is equal to 1, but then the second equation, I'm going to multiply everything by the 3, so 3 times negative a is negative 3a, then I'm going to get 12c, 3 times 0 is just 0. Then I can add those two equations together. 3a minus 3a is just 0, so that was eliminated. And then 2c plus 12c is 14c, 1 plus 0 is just 1. So then when I go through and finish solving that, I should get that c is going to be equal to 1 over 14. So that gives me the value of one of the variables. I still need to find the value of a. So just like I would when I use the elimination method, I can take one of the equations. I'm going to use negative a plus 4c equals 0. If I substitute the c in there, I'll be able to find the value of a. So I'm going to do negative a plus 4 times 1 over 14 equals 0. So this is going to be like 4 over 14. So then when I add a to each side, should be easy enough, I get that 4 over 14 is equal to a, and then technically I can still simplify that, so then I should see that A would be equal to 2 over 7. So that gives me the values of A and of, the values of A and of C. So then from there, I know that my original matrix looked like this. So I have the A and the C. And a lot of times at this point, I like to kind of start writing those in. So again, I knew my original matrix, I wrote it like this. So then when I go to fill in the values of A and C, I know the A was 2 over 7. And then if I look back up at the C was 1 over 14. So I can write those two in there, and I just still need to find the values of B and D. So I can get those, though, by solving this second system. So kind of like the first one, multiple ways to solve it. I'm going to start by multiplying the second equation by a 3. So I like to rewrite my system, so I'm rewriting just the first equation, but when I go to do the second one, I'm going to multiply everything by that 3. So I get negative 3b plus 12d equals 3. So when I do that then and I add my equations together, the b should be eliminated and I get 14d equals 3. So then d is going to become 3 over 14. And if you want to write that in your final system, you sure can. And then when I keep going to solve this, then I can pick one of the equations to substitute the d in there, and then that'll help me solve for b. So I'm going to choose the second one, opposite of b plus 4d equals 1, and I'm substituting the d in there. So I got opposite of b plus 4 times 3 over 14 will be equal to 1. So that's going to be like a 12 over 14. Then I'm going to subtract 12 over 14 from each side. So that leaves me then with the opposite of b being equal to technically 2 over 14. I'm going to save the simplification for at the end, but b will be equal to negative 2 over 14, which is the same then as negative, that'll be equal to the same, equal to negative 1 over 7. So that's the value of b, and I can fill it into my matrix. So if I look back at everything on there then, I had my A, my B, C, and D. And just with the order, that's the order that I solved, and they didn't come up in like alphabetical order or anything, but that doesn't matter because I just make sure that when I go to write the matrix, I'm just following whatever I had in my original system. So I had it as A, B in the first row, C, D in the second row. So then I'm substituting them in like that. If you wanted to check this, which you could, you would want to do your original matrix times what you just came up with. And if you got it correct, you should be getting the identity matrix. Hopefully this was helpful. Thanks for watching.